Welcome, everyone. So it's Frédéric Perret, Marketing Manager of PowerSys. I'm really glad to welcome you for this last day of our work conference for JMAG and pacing today. So I will start first with sharing with you the available recording of the yesterday sessions. So I'm going to share my screen. Up. Frank, do you confirm we can see my screen?
Yes.
Oh, okay, thank you. Perfect. So yesterday we had a different presentation, and the recording available are the following one. So the presentation of Amadeo Vanini from University of Pisa and Nottingham. We also have the presentation of the Jaguar Land Rover team, so Nirmalia Panigrai and Vinayak Gupta. The presentation of the Technical University of Darmstadt from Robin Koster and Dr. Björn Dissinger, and the presentation of Adrien Michel from PowerSys, and the two last one are the one of Vitor Montero from the Universidade Domino, and the presentation of Dr. Antonio Lazaro from the Carlos III University of Madrid. So again, this recording will be available within this morning, and you will have access to them, whether if you go on the agenda and you click on the session you are interested in, or in the video gallery on the Whova platform. Now, what is the plan of our last day of the users conference? So we will start at around, I would say, in 5 minutes with my colleague Didier Zefac from PowerSys. He will present the multiphysics study, so compatible with 3 coupled analysis of magnetic field, heat, and structure. Then at 10:20 a.m., Zoltan Nadjuvari from Rolls-Royce will present how to use JMAG in a multidisciplinary, multi-platform development environment. At 11:05 a.m., Pascal Berezi from Fraunhofer will present multiphysics simulation for electrical component design with MPCCI. And at 11:50 a.m., Peter Stopp from our partner Gamma Technology will present a multidisciplinary approach to integrated motor modeling using GT Suite and JMAG. In the afternoon, we will have a last presentation for JMAG, exceptionally, with my colleague Hamed Shob at 1:40 p.m. about the efficiency map improvements. And then for the rest of the afternoon, we will go on with the pacing presentation. So 2 presentations from Fabio Brucchi, working at Semicron. So at 2 p.m. and at 2:20 p.m. So the first one will be about the flying capacitor boost in semi-top E2 in PV application. And the other one would be about 1200 volt diode technologies comparison. And then at 2:40 p.m., we will have the presentation of Amit Kumar from PowerSim about the resonant converter design and optimization. Finally, I will close our user conference at 3:10 p.m. So by also announcing the winners of our small game during the conference. So I hope you will have and you will enjoy this last day of the conference. Thank you very much. And I will now introduce Didier before his presentation. So Didier has more than 7 years of experience in JMAG simulation and as a support engineer at PowerSys. Didier has received 2 master degrees, the first one in computational engineering for FEA simulations of phenomena governed by the fluid and solid mechanics. And his other degrees is in mechatronics for synergistic integration of mechanical engineering, electronics, and intelligent computer control in design and manufacture of products and processes. In addition of his work on GMAG, Didier also worked on multiphysics CFD tools, which is a really great help and also expertise for us to provide a complete solution for electric motor design and optimization. So Didier, it's now your turn. I'll let you do your presentation. Thank you again.
Okay, yeah, thank you. So can you hear me?
Yes, we can.
Okay. I will share my screen. So please let me know if you can see my screen.
Yes, we can.
Yes. Okay. Okay. So thank you to joining this user conference about the about GMAC and PSIM. So the topic of today is about the new feature on the multiphysics coupling analysis in GMAC. So today I will try to present you this new feature that allows us to make a three-way coupling inside GMAC. So the presentation will be divided into three parts. So in the first time, I will present you the coupling analysis that you have inside GMAC and also introduce this new feature about coupling analysis. And then I will also present some application that we can where we can apply this new feature. And to finish, I will also present you the advantage and also the limitation of this new feature. Yeah. So regarding the internal coupling inside GMAC, so you know that GMAC inside GMAC you have different solver or different analysis. So you have the magnetic field to calculate the magnetic field distribution inside the motor. You have the thermal for the temperature analysis. You have the electric field for the current density distribution. You have the mechanical analysis to check the deformation or the stress of the structure of the machine. So with the whole version, you are able to make a two-way coupling by combining two analysis. So for example, the magnetic and the thermal. So in the magnetic, you calculate the loss, you send the loss to the thermal, and where you will calculate the, you will evaluate the temperature, then you send back the temperature to the magnetic, and you can make the loop. So here you have the different two-way coupling that we can build inside GMAC. But now with the new version, it is possible to make a three-way coupling using three solvers. So first the thermal, where you were able to evaluate the temperature. Then you have the structural analysis, where you'll be able, based on the temperature, for example, you're able to evaluate the displacement and the stress. And you also have the magnetic field, where you'll be able to evaluate the forces and the losses. So, but here with these three solver, you are able to make a loop. So the process is very simple to run. So in the first cycle or first step, so you will start the thermal analysis in order to initialize all the domain. Then GMAC will run next time the structural analysis, where you will try to evaluate the displacement and stress based on the temperature sent by the thermal. And in the last time of the first step, so you will have the magnetic field analysis, where you evaluate the electromagnetic forces and the losses based on the output data of the structure of the thermal and structure, so the temperature, displacement, and the stress. So, and then into the next cycle, it will do the same process and so on. Yeah. The advantage of the two-way coupling is that you are able to manage the simulation time. So you will have different possibility. So the simple way is to define the same time for all the analysis for each analysis. The next case is to define the different time interval. So here you can see that the time interval of the thermal analysis is different from the time interval of the structural analysis, which is different from the magnetic analysis. We also have another case where the total simulation time is different, and also the time interval is different. And the last possibility is that you can combine transient thermal and transient structural with frequency analysis of magnetic. Yeah, this is possible. Okay. So the first application that I want to show you is about the sample thermal expansion effect on the stator. So here I will try to simulate, for example, the effect of the temperature into the deformation of the stator shape. Yeah. So this is the three analyses that I will build. So the magnetic, where I will calculate the losses, and then the loss will be sent to the thermal, where I will calculate the temperature. Here into the structural, I will calculate the displacement and the stress, and I will make the loop between the two analyses to exchange some data. Yeah. So here you can see that here the structural will send the displacement to the thermal, because the displacement can affect the thermal coefficient. So like the thermal conduction coefficient, or the thermal conversion coefficient. Yeah. And also the displacement and stress can be sent to the magnetic, because the material property can be depend on the displacement and the stress. Yeah. So let me go back to JMic. Okay. So this is the 3D model that I built. So here is that here I try to run in the first time a one-way coupling. So one-way coupling means that I will run the data. I will run firstly the magnetic analysis to calculate the loss. Then the loss I send to the thermal, where I will evaluate the temperature, and the temperature can send to the structural analysis to evaluate the stress. But here with the one way, there's no loop between the analysis. And here you can see that I have created the analysis group. So because into JMic you have the advantage to create the analysis group, where you can group several studies around it. Yeah. So let me start with the thermal. So here I can duplicate it. Let's say way. So into the setting, the first thing to do is to go to the study property. Here I will select, I want to make a direct coupling, yeah, to make a loop, and also into the study condition. Here the setting is standard, like the normal thermal analysis. So here you will need to define some heat source condition in order to import the loss calculate into the magnetic calculation. So here, if I duplicate, here you can see that I run a one-way coupling, and here I specify the magnetic calculation just to import the all the losses. But here I don't want to run the one way, I want to run the two-way. So I will select a two-way coupling. So I will try to do that for I can also do that for the iron loss, because here I can also import the losses. So here I will say that I want to make the loop with the magnetic calculation. Okay. And also the other losses, like the magnetic current losses. So here I will say that I want to make a loop. Okay. And also for the casing, the housing. So here, because in the magnetic, I'll also calculate the eddy current losses that you have into the kidney. So here I can also say that I want to make the loop with the magnetic calculation. Okay. So to take into account the displacement calculated by the by the mechanical, so here you can add the displacement condition. I will apply it to the stator only. See here, I will select the coupling. I can define the name stator. Okay. So this is the first thermal three-way analysis, and here I will also do the same setting for the magnetic calculation property. Coupling. Here I will select direct coupling. Okay. Sorry, let me duplicate the calculation. Coupling. Yeah. Property. Coupling. I will select direct coupling. Okay. So here into the matrix, so the setting, the condition is the same like the normal modeling of the magnetic calculation, but for the coupling with thermal, so you need to add the heat source condition in order to send all the losses to the thermal analysis. Yeah. So, but to take into account the stress and the displacement, so here I can also add the displacement condition. Say for the rotor, for example, yeah, I will say direct coupling, stator. I can also add the stress distribution. Yeah, I will say one-way coupling. So here I have now my my magnetic model for three-way coupling. So I will do the same with the structural. So for the structural, here is that I have defined some precision. Yeah. I also define some load. So the load is the temperature. So here I will say I want to make a direct coupling. Okay. So now it's finished. So here I have my thermal model. I have my magnetic model and the structural model. Then I can create the analysis group. Wait. Then I will select all the three analyses. Then here you will see that here you will have a new analysis group with the three solver. Yeah. So I can go to the analysis group property. Yeah. Sorry, I missing to choose direct coupling. Sorry. This is direct coupling, and then select the three-way, sort of a, okay. Then I can go to the analysis group property. So here, so I will keep the setting of the thermal like is it. So from the magnetic analysis here, so because I have the iron loss calculation from the rotor and stator, so here I will say that I want to import. So I want to exchange the average losses of the magnetic to the thermal. Yeah. Also here from the structural, so I will say that I will use the same mesh with the thermal. Okay, so now I can run my analysis to the scheduler. So you go to scheduler and run. So I will open the model that I already ran. Show you some result. Let's see the thermal result. So here I can show you average temperature for each part. So here you have the coil, you have the case, you have the rotor, magnet, shaft, and stator. You can also play a little bit just to see how the temperature is changing. I can also show you the structural. So for the structural, here you can see. So the red one is the position of the initial shape. Then here maybe I can increase a little bit the scaling factor. So here you can see some changing. So this is the displacement. Here I can also show you the stress. What means the stress here that you have inside the casing and the stator. I also from the magnetic. So this is the displacement, but you can also check, for example, the losses. Let's see, two losses, right? Remove. Let's see from the magnet. Let's see the loss from the magnet here. I can also show you the iron losses if you want. This is the iron loss from the rotor and stator. Okay. Okay, so this is the first example using the PEMSEM motor, but you also have another example with the reactor. So where we check the effect of temperature, press, and deformation on the magnetic circuit. Yeah. So you can apply this three-way coupling on any type of electromechanical system. Regarding the advantage and limitation, so for limitation, we cannot restart the three-way coupling. So only one study can be specified for each solver. So for example, you cannot run, you cannot combine two magnetic with two thermal with two structural. So you only need one analysis per solver. So into the magnetic analysis, you cannot model, you cannot create axisymmetric, you cannot use the axisymmetric models. And when the simulation is very large than the thermal and structural, so you cannot use the loss averaging function. Yeah. For the thermal, so the three-way grouping does not support the steady-state thermal analysis, and also the contact cannot be taken into account. For the structural analysis, so if you define the motion, the rotation motion or transformation into magnetic and thermal, so this cannot be, the displacement cannot be taken into account into the structural analysis. And also the material, where the property is depend on the temperature, when it depends linearly or non-linearly, so it cannot be used. The frequential, so the structural analysis cannot be run with the frequency solver or modal transient solver. So regarding the advantage, so different mesh can be used. You can also define high order elements, so first and second order element into the thermal or structural analysis. You can define rotation, translation, arbitrary motion condition only on the magnetic and thermal, but not into the structural. Nonlinear material without temperature dependent can be used with into the structural analysis. We can also apply the loss of averaging function. We can define different type of simulation time. So the tree solver can have different simulation time. We can also speed up the calculation by using the parallel computing function of GMI. So also optimization can be used to run the three-way coupling analysis. So for the other demo, so other features, so you can follow this into YouTube. So we have a lot of demonstration on YouTube. So thank you for for your attention.
Okay, thank you very much, Didier, for your presentation. So we may have 1 or 2 minutes before the next session for some question from the audience. So feel free to ask your question on the Wova platform or directly in the Q&A session in the Zoom. So I've got one question, Didier, for you. Would it be possible, for example, to have the effect of the temperature and the nodal force into the structural calculation, and then also add centrifugal force in the structural calculation, and output the total displacement into, so send back the total displacement into the thermal and magnetic. So the displacement would be due to centrifugal force, nodal force, vibrations, and temperature. So something like thermal stress or thermal expansion.
I think normally, yes, it is possible to do that using so for example, into the structural analysis, you can make a static calculation to check the effect of centrifugal force into the rotor. Then you send the stress and you send the stress and displacement to the magnetic, yeah, and the displacement to the thermal. Then you were able to make the
yes,
coupling.
but the displacement, for example, I would like the displacement not only be due to the centrifugal force, but also nodal force that is calculated from the magnetic, and
yes.
also due to temperature, due to the thermal expansion.
Yes, so for the structural, I think you have several conditions that you can apply. So you have the electromagnetic force,
okay,
you have the centrifugal force that you can apply.
and maybe
Because
thermal
here,
load.
yes, here I only use temperature load, but you can use all this load.
Okay, so might be possible, yeah. Okay.
Yeah.
Thank you very much, Didier. So I think it's time now to switch to the next session. So please join the next session by starting the Zoom meeting for the next one. Thank you for following this session. Thanks to you, Didier, for presenting this new feature.
Thank you.
Bye. See you in the next session.
See you. Thank you and bye.
Bye.